In the previous videos, we looked at various testing techniques like unit testing, integration testing, system testing. And if you've noticed, in all of these testing techniques, we write tests after we write the code, right? And that's the natural way that we go about doing testing, right? But another strategy which is used especially in agile processes is this technique known as test-driven development, or TDD. So in TDD, we write tests first before even implementing the functionality that we want to implement, right? So we write tests first for the functionality, and then we go about implementing that functionality. And as the name suggests, we drive design and development of that functionality from tests. So we iteratively write tests to implement a functionality, implement that functionality, then write another test and implement that functionality, sub-functionality, and so on. So we organize all our activities around verifying small features or functionalities that we have built. So let's see how test-driven development works. So let's say we were building a small functionality or a function or a module, right? So the first thing which we do is we express this requirement or feature or user story in the form of a test, right? We have not written any code yet. We are just specifying what the test is. And then we create this test and we run this test. And since we have not implemented the feature, of course it will fail, right? So we deliberately create a test and make it fail. And now the next step, we create the minimum code to meet the needs of this test. Now our goal is to somehow make this test pass, right? So we implement the minimum code which is required to make this test pass. And after we have done that, we run the test and see that it passes, right? So now for a small functionality or feature, we have designed a test case. Initially it failed. Now we wrote the minimum code to make it pass. And now we refactor this code, right? So we now know that this code ensures that the requirement is satisfied. Now I try to refactor this code to make it, for example, more modular, more elegant, use the coding practices which we learned in the previous weeks, right? And we refactor this code so that it still passes the test, right? So this is the mantra for test-driven development. So this is known as Red-Green-Refactor. First, we write a test and we see that it fails. Then we write code which will, the minimum code required to pass that test, that is green. And then we refactor the code and make it better. And this might be for one small sub-functionality. Then to implement some other sub-functionality, we again iteratively follow this test. So we again write a test for that next sub-functionality. It fails, we write minimum code, and then we refactor. So we follow this cycle of Red-Green-Refactor for each sub-functionality until we have built the entire functionality. So now that we have seen what test-driven development is, let's try it out with a small example. So let's try creating the isPrime function which we saw earlier, right? So I'll create a new file called isPrime, right? And I want to create a function called is prime, which takes a number as input, right? And let's see how we can use TDD to write this function, right? So now in test-driven development, what we do is I start by creating tests, right? So I write, let's say I create a test file, right? And from my is prime function, I import is prime. All right. So in TDD, we start by writing tests, right? We make tests fail first, and then we write the minimum code to pass that test, and we refactor, and we keep on doing this, right? We iterate. So let's think of the first test case, right? So let's say we want to test if a number is not prime. Okay, so if I want to test if my number is not prime, and what I want to do is I want to assert that if I pass a non-prime value, then it should be false, right? So whenever I pass a number which is not prime to the is prime function, it should return false, right? So let's try running this test. So I say PyTest, and it should fail, right? So this is the first part, which is the red. Now I will write code such that I'll write minimum code such that this test should pass, right? So now let's look at our function, right? So the logic is I will iterate from let's say 2 to the number, right? And how do I know if a number is not prime? So if that number mod I, right, equal to 0, then I return false, right? So in this way, I have just created, or I have just implemented a sub functionality or a small part of the is prime function, right, which just checks whether a number is, just checks for non-prime numbers, right? Because that is the test for which the test I want to check, right? So now if I again call PyTest, I see that my test has passed. Okay, great. Now what I can do is I will write another test to check if the number is prime, right? And I will write an assertion where I will call is prime for a number, let's say prime, for a prime number like 5, this should return true, right? But in this case, we have not modified is prime to check for prime numbers, right? So if I run PyTest, right, this function, right, this assertion is not satisfied, right? It's false. So this test fails. Now I go back to my function and I try to see when, or try to implement the logic for returning true when it is a prime number, right? So when is the number prime? When I iterate through all the numbers up to num, right, and up to num minus 1, and it is not divisible by any of those numbers, right? So that means I can return true in this case, right? So let's now, when we run PyTest, we see that both the test cases have passed, right? So in this way, we have incrementally and iteratively built this isPrime function, right? And the test cases has driven the development of this function, right? And that is the power of TDD, where you can incrementally test as well as build your application or build your program, right? But now in this case, we have not checked for, let's say, the number 2, right? So if I want to create, suppose the number is let's say 2, so assert, does this function recognize whether 2 is prime? Okay, let's run this, right? Even for 2 it is working, right? And now I check for, let's say, if the number is 1, so 1 is not a prime number, so it should return false. So let me check, and here we see that this test case fails, right? So then now I go back to my code and I realize that, I'm just checking from 2 onwards, right? So maybe at the start here I say if the number equal to 1, right, I return false. And now if I run my test cases again, right, even that has passed, right? The same thing for, let's say, 0, right? If the number is 0, again, I want isPrime to return false. It doesn't, right? So then again, I go back to my program, and let's say for 0 as well, it should return false. Oops. Right? So we see that all the test cases have passed, right? So in this way, we can use TDD to build, right, simple as well as complex programs, right, where we iteratively create test cases and we follow the mantra, right? We first make the test case fail, then write minimum code to pass the test case. And once each test case has passed, then we try to refine and refactor our code to make it better. So this was an example of how you can use TDD when you write programs.